Climate change is one of the most important problems we face. It is so catastrophic to think what will happen if we disrupt the climate pattern that we have, because agriculture depends on it, the control of plant and animal diseases, the control of human diseases depends on climate. And so when we talk about climate change, we're talking about something that is so intrinsic to human well-being. It is not a trivial subject. It is absolutely fundamental. And let me just give one example of this. The human species, modern human beings, evolved about 200 to 300,000 years ago. During that period of time that our species, us, have been on the Earth, climate has changed from cold to hot to cold to hot. There have been ice ages. But most of the time, it hasn't varied widely. Yes, ice ages coming down over the northern part of the hemisphere in Europe and North America. Yes, that's very serious, but it's been relatively stable, and in particular, about 10,000 years ago, people changed from hunter-gatherers to agricultural. When we were hunter-gatherers, there weren't very many of us. At most, the population of the Earth, if we were still hunter-gatherers, could probably not be more than 500 million at most. Well, we are now at over 7 billion. And there's a reason why we're over 7 billion. About 10,000 years ago, people started a process that we now call agriculture. We learned how to plant lots of crop plants. We learned how to domesticate livestock. And during the last 10,000 years, the climate has been quite stable. So at the very time when we became agricultural, our population went to much higher levels, and the climate has been very stable during that time. So our current condition is one in which our very existence depends upon the climate not making many changes as it was 10,000 years ago. Now let me fast forward from 10,000 years ago to 300 years ago, 1700. Before 1700, people knew about coal. It was known back 4,000 and 5,000 years ago. People used it in very small amounts. You could burn it and make your house warm. People learned to heat the raw iron and then work the iron into tools. So coal was around, people knew it. But 1700 years ago, something really, really major happened. And at one level, you might say, what does all this have to do with climate change and shale gas? I'm getting there, but you have to go through coal first. Because in England, people learned to turn coal into something that had never, ever happened before on a large scale. Coal, you burn it, you get heat. You put your hand over it, you warm up, it's heat. Thomas Newcomen in 1712 made a machine called the Newcomen atmospheric engine, which turned heat into physical motion. You could make something go up and down mechanically. There had been water wheels and wind power before that, but the coal-fired operation to make motion was incredibly new. And essentially what happened from 1712 until 1850, first in England, and then it has spread all over Europe, North America, Japan. It is now spread essentially almost all countries, and if countries don't have this use of fuels, they soon will, because they want them. Between this period, 1712 to 1850, in England, the use of coal just exploded. It went from hundreds of tons per year to hundreds of millions of tons per year. Then in the 1850s, people learned how to poke a hole in the ground and get oil. And at first, the oil wasn't very useful. In the United States, which was one of the very first places to develop oil, we used the first oil mostly for kerosene, lighting, replaced whale oil. But then the automobile got invented, and suddenly you could turn the heat of burning oil into mechanical motion and move something down the road. The first was actually the steam engine for railroads, and then the internal combustion engine for automobiles. Then in the 1880s, people learned to turn a very unusual laboratory phenomena called the electrical effect into massive amounts of electricity. And they hooked the ability of burning coal to make motion to make electricity. So the use of coal exploded again. And when the first oil was produced, gas was present many times, and it was useless. It was dangerous. It would come out of the well, you have to burn it and get rid of it. No way to sell it as a product. You couldn't make any use of it. But by the early 20th century, people had figured out how to capture the gas, and if you burn the gas, you can make electricity. You can heat things. You can turn the gas into other chemicals and make all sorts of products. And so we've got this from Thomas Newcomen in 1712 into the early 20th century. We have coal plus oil plus gas, making electricity, and the use of these fossil fuels just absolutely changed life. And, more importantly, it made it possible to go from a population of about 1 billion people to 7 billion people. If you ask me, can the Earth support 7 billion people without these energy sources, I would say I doubt it. There has to be some energy source, or the 7 billion of us, not all of us will continue to live. The reasons are pretty simple. Some of the most important are you can use natural gas to make fertilizer. With fertilizer, you change crop yields from 1 ton per hectare to 6 or 7 tons per hectare. A vast explosion of food production. With all this energy, you can manage water. You can bring clean water to people. You can treat sewage. The control of disease goes. Many more people are healthy because when you go into areas of low energy, you have sick people, and it's mostly sick because dirty water. We can't keep the sewage separate from the drinking water. Energy allows us to keep the sewage and the drinking water separate, and it allows us to treat sewage and make much cleaner water. The healthcare system, which is essential for survival of many people, it runs on energy. So in no way do I ever want to imply that I don't think energy is important, and I would be the first to say these fossil fuels, coal, oil, gas, produced enormous benefits. I'm quite sure I would not exist today if we did not have those. Now, we get a big problem though. You can't burn fossil fuels without making carbon dioxide. And so we have put hundreds of millions of tons of carbon dioxide into the atmosphere. Now, when Thomas Newcomen first made his engine, the extra carbon dioxide he added to the atmosphere, no big deal. It didn't matter. It was such a small amount. And for the first 200 years, 1700 to 1900, it didn't matter much. But after 1900, it began to matter more and more. And right now, the best science we have, and these are all of the national academies of science in the world, the Intergovernmental Panel on Climate Change, these collections of scientists are as unanimous on the fact that this carbon dioxide is going to cause climate change. They are as unanimous as I have ever seen any group of scientists, anytime, anywhere, on any subject. Mostly scientists like to argue with each other. I think this causes this. No, 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 you're wrong. That's not the way it works. It works this way. And they sit there and they argue. I mean, that's the process of science, try to find out, does A cause B or does C cause B? Or do neither have anything to do? It's something else that we haven't found yet. So when scientists find themselves in massive agreement, to me, you have to take that very seriously, because the process of science encourages argument, not agreement. And the fact that the scientific community is virtually unanimous that climate change is happening, and it's because of carbon dioxide, and the models predict unhappiness, drought, massive changes in precipitation, so instead of getting small amounts of rain, you get huge storms of rain. The disease patterns change. Agricultural processes look to be interrupted. Water processes, the ability to capture water and make sure that everybody has good, clean water, that gets disrupted. So this is what we're faced now with. We have coal, oil, and gas used in massive amounts, supplemented by nuclear and hydropower, and a little solar and wind power, that keeps 7 billion people alive, and probably can keep 8 billion people alive, and probably 9 billion people alive. But we're changing the climate, and that threatens everything. So we have to be able to control our modification of the climate. And that means you have to get rid of carbon dioxide emissions. There's been a lot of discussion, well, do we reduce carbon dioxide emissions by 10%, 20%, 50%? The arguments I'm now seeing by scientists who are working in this area is, no, it's probably more like 80, 90, or even 100% to preserve climate. Otherwise, if we keep emitting any carbon dioxide, it's really serious. So I draw one lesson from this. We need the energy. Human life depends on it. The prosperity and the healthfulness of human life depends on energy. And the fossil fuels are not going to work. They just are dangerous. We have to start looking at them as, oh, that is not good stuff, that is bad stuff. Now this is a total transformation of the way people think. And I will be the first to say, do I emit a lot of carbon dioxide in my life? I certainly do. Now I have to think, okay, I do, that's not so good, so what are we going to do about it? And this is where we get to gas and climate change and alternative energy. Gas has one good feature that I will acknowledge right up front because it's true. If you burn coal, you get a certain amount of heat and you produce a lot of carbon dioxide. You can burn gas, get the same amount of heat, and produce about half the amount of carbon dioxide. So on the surface it looks like, well, gas would be good. At least you get 50% reduction of carbon dioxide. Now there's some other problems about getting gas, and do you really get 50% less of the climate change effect, and I'll get to that in a minute. But let's just stay with the simple fact that, yeah, you get less carbon dioxide for the same amount of heat. So some people have taken that same amount of heat, do all good things with it, make motion, heat things, make chemical processes, and said, well, okay, we should use gas instead of coal and oil, and then we'll be better off. Well, there are two things wrong with this. First of all, it only reduces the carbon dioxide by 50%. That's not enough. it's more likely that we need to reduce carbon dioxide by 80 to 100%. And the closer we get to 100% reduction, the better off we are. Because even 80% reduction may be not enough reduction. So gas, at that very simple level, doesn't help the climate change. It's still a carbon dioxide emitter. The only thing you can say is, well, maybe it reduces the carbon dioxide emissions some. And people have been making this argument in the United States very, very strongly. Now let me bring in the complication about getting the gas and climate change. Gas is mostly methane, carbon and 4 hydrogens. Like carbon dioxide, methane traps heat in the atmosphere. When you produce gas, it is almost certain some of the gas that's coming out of the ground will be lost to the atmosphere. Sometimes it's called fugitive methane, fugitive gas, lost gas. When this methane goes into the atmosphere, it acts just like carbon dioxide and traps heat. And in fact, it's a more powerful trapper of heat than carbon dioxide. So, when you produce gas and some methane escapes from the process, it either escapes from the well, or you have to purify the gas, so you have to process it. It escapes during the processing. You have to transmit the gas through pipelines. Some gets lost in those pipelines. When the gas comes into, for example, in my house, we cook with gas. When the gas comes into my house, some is always lost. When I turn on the stove, first the gas comes out and then it catches fire. Well, what happened to the gas before it caught fire? Well, it's methane that went into the atmosphere. So even in my house, we're losing a little methane. You can't make gas and use it without losing some of it. Now, there's a big argument. Are we losing 1 or 2%? Are we losing 5%, 12%, 20%? At some level, I don't think that's the right question to ask. It's an important question, but it's not the central question. Because the real point is, if you make gas, if you produce gas, you're going to lose some, and that contributes to climate change. And when you burn the gas, you get carbon dioxide, and that contributes to climate change. There's no way of dealing with gas without dealing with climate change. So what this leads me to conclude is, coal, yes, we have to move away from coal. Oil, yes, we have to move away from from oil. And then I would add, and gas, yes, we have to move away from gas. So in terms of, am I in favor of fracking, the most important thing I would say is no, because you cannot produce gas without contributing to climate change. It doesn't matter how you do it or how well you do it, it's still a climate change contributor. Now, in addition, when you frack, there are all sorts of other health problems that occur. The chemicals that are used in the fracking fluid, the sand that is used in the fracking mixture, all of these cause health problems. The noise, the stress, the air pollution around the gas melts. There are lots of health problems around the production of gas. But here's, to me, it's a crucial point. Even if government regulation could come in and say, you must produce the gas with no methane emissions and no health problems. And suppose the company said, okay, that's what we'll do. And suppose they put good engineers to work and they prevent the health problems and they prevent loss of gas. I would say, not good enough. You still have the fundamental problem. You can't capture all the methane. Some's going to escape. That's bad. And when you burn it, you're producing carbon dioxide, and that's unacceptable. So fracking is no solution to anything except one thing, and this is really important. What fracking solves is the ability of a gas company to make money. That's the only thing it solves. And they can make a lot of money, and that's why, of course, they want to do it. If you produce gas by fracking or any other method, you can take it, you can sell it, and you make a lot of money. Now, for people who need to make money, of course, that solves the problem. But it does not solve the climate change problem. It does not solve the energy problem. So for me, the issue is move away from coal, move away from oil, move away from gas. What do you put in its place? Because we still have to have energy services. First thing is, well, make sure every bit of energy you use is used as efficiently as possible. Use as little energy as possible to do what we need to do. Make clean water, run health systems, produce agricultural yields that are quite productive. We need to do those things, and it takes energy. Then, efficiency can take you a certain way towards solving this problem of don't use fossil fuels, but keep the energy services. The next things are, well, we're going to need some other additional forms of energy, and here's where you get a couple of questions. Well, what about nuclear? Some people say nuclear power, as it produces electricity, has no carbon emissions. When you look at the entire cycle of nuclear power, there are carbon emissions that are important. But even more importantly, and this is not the subject where we can get in today, but nuclear power is not the technology of choice. And the reasons are twofold. First of all, it's extremely expensive to build the plants. Huge amounts of money have to go in. And second, there is no way to do fission of uranium to produce heat, to produce electricity, without making highly toxic radioactive waste products. And sooner or later, those waste products get released to the environment. In catastrophic accidents like Chernobyl and Fukushima, we've seen horrible catastrophes when this stuff gets out. There is no way to make a nuclear power plant that the engineers can say, we will never have an accident. That's simply impossible. Every machine that people have ever made breaks, fails. At a certain period of intervals, we will get catastrophic nuclear accidents. And when those happen, the areas around them are absolutely devastated. People have to leave. We lose huge areas of land. I like to say about Chernobyl, in the United States, we have a very small state called Rhode Island. It's in New England. I like to say, how big is the exclusion zone around Chernobyl? About the size of Rhode Island. And then I ask people in the United States, imagine Rhode Island evacuated. Rhode Island has about 1 million people in it. If Rhode Island were to be evacuated, it would be a catastrophe for the United States, just like Chernobyl was for Ukraine. So nuclear is not the way to go. So to me, what that leaves us with, efficiency, yes, and then solar and wind. Then you have to ask, well, is there enough solar energy, is there enough wind energy that we can actually get enough energy to do what we need to support 7 billion people? And this is a long discussion, so I'll just give you the short answer. The answer is yes. There is enough solar energy, there is enough wind energy. Do we know how to obtain it in a usable form? Are we really skilled and good about capturing that energy and putting it to work? And the answer is we are just barely at the start of getting good enough. Solar and wind produce energy increasingly in the United States, and Ukraine is starting to produce solar and wind, but they're very, very tiny compared to fossil fuels and nuclear. But I'm very optimistic that if we tell engineers, we want you to produce an energy system which is based on efficiency and solar and wind, over about the next 20 to 30 years, we will get extremely skillful and be able to do this. And that coal, oil, and gas will become obsolete, nuclear will become obsolete, and I should add that, of course, we will continue to draw on hydropower, rivers and dams and hydropower. But hydropower has limits. There are only so many rivers on the earth, and the United States has relatively little hydropower that it could further develop. Other countries have more, but hydropower will be there to supplement solar and wind, and all based on efficiency. And if we can do that, we have maybe a chance of preserving a climate that we can continue to live in and that will continue to support 7 billion people. At least I hope it does, because I have 2 grandkids and I would like them to have a good life. And if we don't make these changes, I really fear that they won't have a good life. So